rationalize the denominator of each fraction and simplify. In exercise A, we have 5 divided by 2 plus the square root of 7. So our goal is to force the denominator to become a rational number. We need to get rid of that radical. And if we recall from a previous example, we learned that if we multiplied a binomial involving a radical, a square root, by its conjugate, we got an expression without a radical. So that's what I'm going to do. I'm going to multiply the denominator by its conjugate, which is 2 minus the square root of 7. In the numerator, I have to do the same thing. And it's always a good idea to throw some parentheses when you're multiplying binomials, to remember to use distributive or the FOIL technique if necessary. Alright, so rewriting this, I now have 5 multiplied by 2 minus the square root of 7 in the numerator, and I have 2 plus the square root of 7 multiplied by 2 minus the square root of 7 in the denominator. Using the distributive property in the numerator, I have 10 minus 5 times the square root of 7. In the denominator, I would have 2 times 2 is 4. Outers would give me minus 2 times the square root of 7. Inners would give me plus 2 times the square root of 7. And the lasts would give me the square root of 7 minus the square root of 7 times the square root of 7. So this would give me 10 minus 5 times the square root of 7. And remember, in these expressions, we have those like terms, and those like terms add up to 0, or combine to 0. So in the denominator, I have 4 minus 7. So this gives us 10 minus 5 times the square root of 7 over negative 3. Now, while it's not incorrect to leave the expression like this, we generally don't like this negative in the denominator. And so what we might do with that is put it in the front of the fraction. Alternatively, we can put it in the numerator of the fraction. And apply the distributive property. So that would give me negative 10 plus 5 times the square root of 7 over 3. So just be aware that the expression can be written a few different ways when you throw that negative in. Alright, let's look at exercise B. We have 4 divided by the square root of 5 minus the square root of 3. As with the previous exercise, I'm going to multiply by the conjugate of the denominator in both numerator and denominator. So square root of 5 plus the square root of 3 in both the numerator and denominator. So then this would give me 4 times the square root of 5 plus the square root of 3 in the numerator, and the denominator is the square root of 5 minus the square root of 3 times the square root of 5 plus the square root of 3. Applying the distributive property in the numerator gives me 4 times the square root of 5 plus 4 times the square root of 3. And in the denominator, I'd have the square root of 5 times the square root of 5. Outers would give me the square root of 5 times the square root of 3. Inners would give me minus square root of 3 times the square root of 5, and the lasts would give me minus square root of 3 times the square root of 3. Again, notice that the like terms in the denominator combine to 0. The numerator, I have 4 times the square root of 5 plus 4 times the square root of 3, and the denominator would be 5 minus 3, which is 2. So I have 4 times the square root of 5 plus 4 times the square root of 3 over 2. Now, we have to be careful here because we can simplify this further. Notice that there is a common factor in the numerator, and that factor is, in fact, 4. Or we could maybe more easily see it as there being a common factor of 2 between the numerator and denominator. So, let me factor out that 2 in the numerator. So I'd have 2 times the square root of 5 plus 2 times the square root of 3 in the numerator, and the denominator is just still 2. And notice now I can remove that common factor of 2 from both the numerator and denominator, leaving 2 times the square root of 5 plus 2 times the square root of 3.